This lesson is using proportional reasoning. So we're going to take all the stuff that we've learned with rates and ratios and unit rates and unit ratios, and then we're going to apply that to solving unknown fractions, if a numerator or denominator. We've already seen a lot of this stuff in the previous lessons, so let's just go over a little recap. So we can write equivalent ratios by multiplying or dividing both the numerator and the denominator, or the right or the left and right hand side of the ratio, by the same value to get an equivalent fraction or ratio. So we're going to look at units as well to include units. We already saw this last time where we had kilometers and hours and meters and seconds. It's a really good idea with these when you're writing them to sometimes, or not to all the time to write your units as well, so we know what you're comparing. Okay, so we look at this one. We see a ratio of 1 to 3. We could multiply both by 3 to get a ratio of 3 to 9. This one over here, we divided by, I know it looks like a plus, but we divided by 2 to get 2 to 1, and we divided 4 by 2 to get to 2. So we divided to get an equivalent ratio. 3 to 9 is equivalent to 1 to 3, and 1 to 2 is equivalent to 2 to 4. So we'll look at an example here. Sam paints 15 square meters, or meters squared, of his fence in 3 hours. The total area of the fence is 90 meters squared. So he's already done 15 meters squared in 3 hours. Here's the ratio for that, or the rate. If he paints at the same rate, how long will it take him to paint the entire fence? So 15 to 90. So I've already done 15. How much longer is it going to take me, or how long is it going to take me to do the whole thing for 90? So again, like we've seen before, we have to either multiply or divide the numerator or denominator by the same amount. So let's look, 15 to 90. Remember, I can kind of reverse it. I can say, well, I could do 15 times something, and you could guess. You could take 15 times, say, like 4, which is 60, or 15 times 6. So there, we found it right away. Or you could do the go back the other way, and you could start with 90. You could start with 90 and divide by 15 to figure out what did I multiply that 15 by to get to 90. And we see 6. So I multiply by 6. I'm going to have to multiply the bottom by 6 as well. So 3 times 6, of course, is 18. And that's in terms of hours. So it's going to take him, Sam will take 18 hours to paint the fence. Which he probably wouldn't do all in one day, of course. He would break that up over probably 3 days, 2 days, maybe 9 hours, unless if he's not working. So we see how to solve equivalent fractions, equivalent ratios. Next example, 5 buns cost $2.50. Now, how much would it cost for 21 buns? Last time we looked at comparing two rates. This time we're going to take one rate and kind of expand on it. So first of all, part A, we're going to get a unit rate first. So how much is it for 1 bun? Okay, so from 5 to 1, of course, we divide by 5. So we're going to have to take 250 and divide it by 5 as well, the price. So 250 divided by 5 is 0.5, or 50 cents. So for 1 bun, it costs 50 cents. Now, how much for 21 buns? 21 buns, right? So that we, like, if I was writing this as a ratio, I could write 1 bun is, for every 1 bun, it's 50 cents. For 21 buns, though, how much is it? And you just have to look at the amount of buns, right? Because now I have a 1. It's very easy to get to 21 because I just multiply by 21. This is the power of unit ratios. Once you have a unit ratio, you have something as in terms of just 1, and you can just multiply it by the value that you want because you're just multiplying by 1. So 1 to 21, and then I take the price, 50 cents, and I multiply that by 21. So I get $10.50. Notice how the calculator doesn't write a 0 after the 5, but because we're dealing with money, it's kind of a good idea to do that. Oops, this actually should have been down here. That is the answer for the second part, part B. So we got the unit ratio. That was right here. And then the second part of this question, for 21 buns, I have it here. So 21 buns, I multiplied both by 21 to get the full amount. Next example. Is each ratio true? To figure out if a ratio is true, all you have to do is divide the top and the bottom and see if it's being, or first of all, just divide the top. Well, you can do both. And then see if it's being divided or multiplied by the same amount, by the same value. So from 240 to 400, remember I can do it kind of reversed. I can say, well, 240 times what is 400? If it's easy, that's great. You can just do it. This time, maybe not so easy because these two numbers don't really divide evenly. So I'm going to start with the bigger number, 400. I'm going to divide by 240, and I get a value of 1.66 repeating. Now, it has to be exact. So I multiplied that by 1.6 repeating. Let's see if the bottom is the same. So I'm going to start with the bigger value, 8. I'm going to divide by 5, and I get a value of 1.6, not repeating. This has just been multiplied by 1.6. So no, those are not, even though they're close, they're not the same. It's different enough to make it not the same. Let's look at the next one. So 240 to 320, again, kind of a complicated one to do in your head. 3 to 4, again, you could maybe do it in your head a little bit. But let's just use a calculator for this one to get the exact amount. So 320 divided by 240, whoops, and I get a value of 1.3 repeating. So again, we're going to be really accurate here, okay? So that was multiplied by 1.3 repeating. Now let's see if the bottom is the same. So I take 4 divided by 3, and I get, oh good, 1.3 repeating. So the same amount. So yes, that one is true. So with these ones, when it's asking you, is this ratio true? Divide the top, divide the bottom, try to figure out if it's by the same amount. All right, next example. So we're just going to solve. This is just straight solving for the equivalent ratios. So I actually have questions that are very similar to this in Workplace Math 10. We just solve for the unknown value on the top of a fraction. So there's a couple ways you can do this. I'm going to show you both. So first of all, we're going to do it the same way that we've been doing it all along, which is just what do we multiply by? So on the bottom, 7 to 21. I mean, I know that right away. It's just multiplied by 3. So the top, we can multiply that by 3. And that ends up being 12 over 21. And this one, we're kind of going backwards, but we're saying, okay, what did I multiply this one by? Or divide this one by? So either way, you can kind of look at the same one. So I'm going to go this way because we have the full fraction on the right-hand side. And we divide that one by 8. 24 divided by 8 is 3. And the top, I divide that one by 8. And of course, 8 divided by 8 is 1. So I get an equivalent fraction of 1. Now, if it was a more complicated fraction, I didn't know how to do it, I'll show you the algebraic method, which it'll confuse you, but that's okay. So if I'm using algebra and I have, say, like an x on top, and the thing is saying, hey, solve for x, what you can do is you cross multiply, first of all. Oops. So cross multiply. If you get the first way, totally just do it that way. But in this sense, I'm going to cross multiply. And I multiply the 4 by the 21 and the 7 by the x. So 4 times 21, oops. So 21 times 4, I know it was 84 already. So I get 84 on one side, and then 7 times x is 7x. Now I have an algebra question, a one step, and I'm just going to divide both sides by 7. So I get a value of, well, we already know it's 12 because we have already done this. But if you didn't, you could solve for the variable on top by using cross multiplication. Might take a couple extra steps, but you know what? If you have big values or you have complicated values, and as you move up, cross multiplication is probably going to be the way that you do, the way that you solve a lot of these types of unknown fractions. But for this course, most of the time they're quite similar. All right, that's the end of that lesson. Hopefully that helps. Yeah, go back and review it if you need to start from the beginning.